Hey, good morning, everyone, and good evening to Mark. Thank you for taking time to
Mhm.
attend. Today we have Mark Rakmilovich. If you don't know Mark, he is a senior director of blockchain product management at Oracle, and he's responsible for blockchain technology, strategy, and the products. He works closely with Oracle development to evolve Oracle blockchain platform in the cloud and on premises based on needs of enterprise customers, right? So he's the go-to guy for Oracle blockchain. Ask any questions on blockchain. I know we are new to this technology and some of you already using it, but it is also important as a database community. We need to understand the blockchain technology because this plays a very important role in our day-to-day life. I think it's very this is why we are introducing new technologies, and Mark is agreed to present on this. And Mark is also facilitates a customer's blockchain journey from rapid experimentation to live production through discovery, sharing industry use cases, best practices. And actually, it's a great profile. I request you to go to our web page. Lot of accreditations from Mark, and we need to learn many things from Mark, by the way, right? So he also helps the set the strategy for Oracle blockchain efforts and guide customers and partners around the world. So let's learn from Mark. And this is a starting session, as I mentioned earlier. Ask all your questions, even if it is a basic questions, it's okay. And Mark's today's session is divided into 5 topics, right? Each session you can post questions. Some of the housekeeping things. One of the important thing is tweet about this webinar. This is the only way you can connect with the other attendees and speakers and make more virtual connections. Use AIOG webinar as a hashtag so that you can search that hashtag and connect with people. And you know how important the network these days, right? Your IT careers, looking for jobs, all the stuff, right? We also invite, as I mentioned, your comments and questions. Please look at the Q&A bottom of your screen. Please ask your questions for speaker at any point of time. Type in only in Q&A section, right? Um, and Mark will answer appropriately. And one more request is please prepare your question properly before asking. Do not type as a query like a chat, right? Let us respect Mark's time. And also use chat box for any support. If you can't hear any logistics, we can help you, myself and Aishwarya. uh, Remember, knowledge is power as long as it is shared. Do not say with you, share with others. So provide your feedback at the end of the session. With that, very warm welcome, Mark, and thanks for your continued support. And I know it's a late evening for you, and so please go ahead and share your screen. Thanks, Mark.
All right, thank you, Sai, and thanks everybody for joining today. Let me go ahead and let's see, share my screen. As Sai mentioned, I am part of the product development team at Oracle that's responsible for our blockchain platform. Let me just to make sure I'm sharing the right screen here, which I don't think I am. Let me do it one more time. Okay, this is better. All right, so hopefully you can see the title page for the deck here. When you get a copy of the deck, my contact information is in these 2 links, email as well as LinkedIn. So if you want to follow up, if you have some questions that come up later that you have not had a chance to ask during the session, feel free. I work a lot with folks across the world on a variety of blockchain topics, collaboration, some of our partners, ecosystem, customers, etc. So I will today go through, as I mentioned, 5 sections. I will start with an introduction into enterprise blockchain. I'm sure for some of you this may be a fairly new topic. For others, it may be something you're already familiar with, so please bear with us. But I'll try to touch on some of the key points of relevance, particularly for folks. I assume a lot of you are coming from the database background, and also try to cover the Oracle strategy in blockchain space and how Oracle is positioning ourselves for success here. We'll then spend a good amount of time talking about Oracle blockchain platform, its capabilities and its advantages. And I'll share some of the customer momentum in terms of the deployments that we have, customers across various use cases and industries, customers who are live in production, and also some partner solutions that have been built on Oracle blockchain by system integrators, by the ISVs, and so on. And then we'll spend some time on another blockchain technology that Oracle introduces here, blockchain tables in Oracle database, which is different from blockchain platform, but somewhat related. And then we'll finish with just a little bit of how we approach working with customers and helping them on their blockchain journey. And as I mentioned, I will pause at the end of each of the sections to take a few questions, right? So pose them on Q&A, and I'll go to Q&A and pick a few questions at a time for each section. And then at the end, hopefully we'll have more time for questions as well. There is a lot of slides in the deck. I'm going to skip a few, probably goes very quickly in the interest of time, but let's begin. And I'll begin with some predictions here. Tonight actually is US election night. Here in US, everybody's glued to the screens and everybody's talking about predictions, what will happen, who will win, and so on. So I thought predictions might be in order. And my predictions are a little bit different. They're about enterprise blockchain, though. So 2 quotes here. One is from Frank Schwank, who is our group vice president of blockchain technologies, who predicted that between 50 and 60% of companies will use blockchain in the next few years. And it's an interesting prediction, and I'll explain what's behind that. And then there is prediction from Brian Belgendorf, who is an executive director of Hyperledger, which is a Linux Foundation open source project, talking about specifically here, if you are in a diamond business and your diamond is not registered in the blockchain ledger, you might have trouble reselling it soon. What's interesting is that when Brian made this prediction over a year ago, he was talking about luxury goods like diamonds, but we're increasingly beginning to see the same sentiments being applied to all sorts of things. It could be, medicine and drugs. It may be all kinds of pharmaceuticals. It may be parts aircraft parts, for example, or automobile parts, or it could be certain minerals. It could be food products or, beverages. We're beginning to see the sort of notion that blockchain authenticated goods are going to carry not just higher value, but are going to be the only ways that you buy things in the near future for many categories of things where authenticity and source origin, sustainable sourcing are important. So I'm beginning to see really this whole area growing very, very rapidly. Now, what is blockchain? Let's start with the beginning here, right? So blockchain is a system for maintaining distributed ledgers in a peer-to-peer network. And that's kind of a systems guide definition of what a blockchain is. Let's take it apart, right? By peer-to-peer network, we mean a network consisting of nodes, right? So there is a number of nodes belonging to different organizations, and they maintain a copy of the data. That's why it's called distributed ledgers. And by ledgers, we don't just mean accounting data that you would typically see kind of from an accounting perspective, but really any kind of data where you store transactions and the state changes associated with those transactions, right? So, and blockchain is a mechanism, is a system that allows for all of these nodes to cooperate, execute trusted transactions, and ultimately replicates the data. So each node has the same values, the same data in the ledger as all the other nodes. That's the important part, right? In order for distributed ledgers to work, to be useful, they have to be consistent. And that replication has to be done in near real time, and it has to be done once all of the participants agree to those updates. So that's called consensus protocol. Consensus protocol enables this near real time replication, and it allows multiple parties that may not fully trust one another to still work together and exchange trusted transactions without requiring a third-party intermediary. Once the data actually comes into the ledgers, into the copies of the data store, it's stored in a manner that's called tamper evident, or some people refer to it as unalterable or immutable. Now, we all know in computer technologies there is no such thing as completely immutable or unalterable data, but it's stored in a way that allows for any tampering to be very quickly detected. And I'll talk about that in a minute. Let's think about an example here where we have a blockchain that's being maintained in a supply chain case by a number of suppliers to an OEM. Let's say a manufacturer, right? They get a lot of ingredients or components from various suppliers. There is logistics companies that do the shipping. There are customers that actually buy the products and so on. So in this kind of blockchain, what the data you might maintain in a ledger is maybe some inventory information, a product information, ingredient information, linkage between ingredients and products, and so on. So what are the key properties of this, right? So the first is that everybody can see the data in near real time that anybody's posting, and so that provides greater degree of efficiency. You don't need an intermediary. You don't need a kind of a data warehouse collecting and distributing all of the data because it's all done in a peer-to-peer manner. You rely on algorithmic trust, which means that you validate through the code, through smart contracts, through consensus mechanism, every update before it's actually updated on the ledger. So instead of just trusting at the relationship level, as an OEM, you're doing business with a supplier one, so you trust they're going to generally do the right thing because you've done business with them for a long time and so on. But you cannot necessarily trust that every transaction done by every person at the supplier is going to be done correctly and follow all of the rules and all the protocols. That's where algorithmic trust comes in, because you can, through the business logic encoded in the blockchain, validate that for every transaction. You have ability for all the participants to see all of the data. That's transparency, right? Gives you visibility, single source of truth, etc. And it's auditable by regulators as well, if necessary. Irreversibility, right? This is a concept of storing data that comes in. So transactions themselves come in with what they call non-repudiation. All of the messages are digitally signed. So there is use of PKI, public key cryptography, in the blockchain, where every message is digitally signed as a private key with a participant. And if you're familiar with PKI, there is private public key pair. The public key is available in the official certificate that's issued, and message can be verified that is properly signed as a private key by using the public key, right? And so there is non-repudiation. And at the same time, you have this cryptographic hashing that links the blocks to ensure that every block is hashed, and the result of that hashing operation is stored in the next block, and then that whole block is hashed, and so on. So you have this hash chaining that essentially allows you to verify that no block has been tampered, and that's the tamper evident properly. Just the daisy chain records that are cryptographically hash chained. So those are the key 5 properties of a blockchain. Now, let's look back a little bit and understand that a lot of the component technologies that blockchain is built on, and when the initial paper was published by Satoshi Nakamoto on Bitcoin, was really a combination of multiple technologies that came together from cryptographic world, digital signatures, crypto hashing functions, Merkle trees, etc., encryption, and distributed systems, peer-to-peer networking, message passing, consensus algorithms, distributed databases with replication, and so on. It's really a combination, if you will, amalgamation of all of these different technologies that brought together make up a blockchain. So if majority of you come from database background, let me sort of contrast a little bit, and this is from Gartner, the difference between a typical traditional application that has a database as a backend. There is some sort of APIs, there is a web application, there is backend and front end. And this is what a typical application stack looks like, to a decentralized application in a blockchain environment. So first, instead of having a single database, we have a distributed ledger, multiple nodes where the data is replicated and the blocks are linked. Then we have a concept of a smart contract. Now, smart contract is a bit of business logic, a little bit like triggered stored procedures that are executed, can be executed in a database, and a little bit like the backend of the web application, right? So it handles the transaction request, it does the validation, it operates on the data that's stored on the ledger, it does get and put operations on the ledger, and so on. And that's a custom business logic. Then you typically have a client that talks to the smart contract, invokes it, runs transactions, runs queries, subscribes to events, and so on. And this is a client application that kind of acts as a backend for the application. And then you have a front end, which traditionally is called the wallet, because in the Bitcoin world, it usually contains your private keys and maybe the balance of your token balance. But really, a client application can be anything. When I talked about an example here in the supply chain environment, it could be inventory management, it could be status of products, it could be certifications of products, country of origin information, any kind of thing. And the client application would then do that. But traditionally, they're still called wallet applications. So that's kind of a little bit of a difference with the database. Now, you might ask yourself, if I have a secure database and a cluster, perhaps, right, for high availability, why do I need blockchain? Well, a few key differences. First, because we call it a ledger, it means that it's append only. There is no such thing as deletes, drops, modifications to the records. It actually is an insert only or append only sequence of records, right? That's how it maintains the history in tamper-evident manner. The data in the blockchain is typically shared across organizational boundaries, the boundaries of trust, without requiring kind of complex data transfer, reconciliation, or an intermediary. So the data store can be shared by multiple organizations, and the job of the blockchain technology is to ensure that, in fact, it's replicated appropriately, and that every node in the blockchain can independently verify and process every transaction. And it can ensure that because it has the visibility into the current data in the ledger, what's called state of the world, right? All of the values in the data store. And then it gets a transaction that says, okay, there is a certain operation we want to perform, we want to calculate some new updates, we want to store that, and they're digitally signed. Then it goes through the calculation process in the smart contract and then generates an update, what's called a read-write set, and that ends up being replicated through an ordering mechanism. There is blocks creation, etc. I'll talk a little bit about that in the future. But fundamentally, the mechanism about data sharing is very different from a database. In a database environment, you typically have an application making direct update to the database. Then if you need to share it with another organization, you would extract it from the database. You would share it in some way, maybe a spreadsheet, maybe a file, maybe some other means of sharing the data, send it to them, and they process it through the application, and then that application makes update to the database. In this case, the replication is done by the system itself, by the network, and it's done after all of the business logic smart contracts have executed the transaction and agreed on the update being valid and consistent. Only then everybody in the network updates the data in the repository. So you have the replication that's controlled by multiple organizations. That means you eliminate single point of failure, single point of control as well. There is no single DBA. And that can reduce significantly the potential for any kind of insider attacks where, if somebody, if a DBA gets spearphished and their account gets hacked, they can be compromised, and then that person can access the database and do all kinds of things in a single organization. With a distributed ledger, you have to do that to many, many organizations. And the other key difference is that in the blockchain environment, you typically have, not always, but typically multiple writers, multiple organizations generating updates. And the idea is to synchronize and sequence the transaction in such a way that all transactions are ordered in the same way, so everybody can see the same sequence. Which, if you're talking about some transactions, particularly in financial spheres, that's pretty important, right? You're doing debits and credits. And, if you, let's say, you have $100 and you have two debits, let's say three debits, 50, 20, and 70, depending on the orders they come in, that may or may not work, right? If you do a $50 debit and then you do a $70 debit and your balance is 100, the second debit will not work, right? So if you do the $70 debit first, then that will work. And then you can do a $20 debit, but then you have only $30 left and $50 debit will not work. So when you have multiple writers, this version control and sequencing of updates is very important, and blockchain ensures that all the nodes see the same transaction order once it gets the blocks. So what makes up an enterprise blockchain? Unlike blockchains that Bitcoins, Ethereum's private blockchains out there that you probably read about and hear about every day. Well, a few key things. First is that there is a membership governance based on identity management, because in an enterprise blockchain environment, you don't want anonymous participants. You want people, you want organizations that can be authenticated and granted access. Then you have the shared ledger, right? That's an append-only distributed system of record that's distributed across the network. You have smart contracts, which is a business logic that contains certain rules, validations, reconciliation, business terms, etc. Whatever you want to code, really, it's up to the application developer to decide what to put into the smart contract. But fundamentally, the property of a contract is that a transaction can be sent to multiple nodes. Each one will execute its copy of that smart contract, or chain code as we call it, independently. They will digitally sign the results. That's called an endorsement. And then that endorsement is shared back with everybody on the network. Now, when I said everybody executes everything, that's not completely true. You can set it up that way, but often you also want to enforce privacy and confidentiality, because in a business context, you have access controls that you need to enforce, right? Not everybody is going to see all of the data. So there is ability in an enterprise blockchain to enforce confidentiality and limit the scope of visibility. And finally, there is a concept of proof that comes in three different ways. First, you have the transactions that are digitally signed messages when they come in to the smart contract for execution, right? So you know who initiated. You can prove that somebody initiated the transaction. Then you have the result that's calculated by different nodes, and they sign those results. So you can prove that smart contract execution has been performed and certain result has been recorded from that, right? And then ultimately the data is stored in the blocks in the ledger in such a way that an auditor coming back after the fact, after the data has been stored, can verify that the block has not been tampered with. Was it sitting there for a minute, a day, a year? You can calculate the hash on the block, compare it with the next block, etc. And you can verify that the data has not been tampered. And all of those components essentially make up the proof, right? So as I mentioned, there is different type of blockchain models out there. There is a growing spectrum. The public blockchains like Bitcoins and Ethereums allow permissionless or anonymous access. By contrast, enterprise blockchains, which is where we are focusing at Oracle, and most of our customers are focusing, are permissioned blockchains where you have known entities, right? There is multiple organizations typically involved in a consortium blockchain. There are some use cases where private blockchain makes sense for a single organization, maybe different line of businesses working together across different legal entities, subsidiaries, and so on. And then you have a concept of a kind of a hybrid environment called public permissioned blockchain. Now, that is a blockchain where the right is validated as still permissioned known entities, but you might provide read-only access to other participants that are not necessarily blockchain members, right? We put public in quotes here because typically it's not completely public. You still have some authentication mechanism, but it's external to the blockchain. Now, what makes blockchain really compelling to enterprise? I touched on algorithmic trust early on, and that's really key because it helps in non-repudiation to reduce the risk of fraud. Records are stored in a tamper-evident manner. It helps to reduce the fraud again. And you have process integrity that's based on the logic encoded in the pre-agreed smart contracts and the consensus mechanisms that are built into the network protocols. You have the benefits of transparency, right? Single source of truth from multiple silos, all available in the ledger. That helps to provide more optimized decision-making, visibility to the data. It's self-regulating because people decide to share the data. And it's shared in a way that creates a built-in audit history because everything is sequenced, timestamped, digitally signed, etc. So you have a audit history that's there for all of the data that you're sharing. You can avoid intermediaries, or at least you can reduce intermediaries by doing this in a peer-to-peer environment. That helps to speed up the transactions, improve customer experience, lower the cost, and often also helps with agile onboarding of partners, vendors, and other ecosystem participants. And then you have the automation. Because you have the data that's available from multiple silos in the blockchain shared ledger, and you have the smart contracts that allow you to run business logic, you have ability to do real-time reconciliation right? A good example, if you think about in a supply chain environment, you have purchase orders being issued between companies, and you have invoices against purchase orders, and then maybe you have some shipping documentation. Well, if you can collect all of that in one place and make it available in the ledger, you can then have smart contracts that matches the purchase order lines against invoice lines and verifies with the shipping documentations that have been actually received and accepted. And then that allows you to trigger not only reconciliation, but actual settlement and maybe payments as well downstream. This provides, again, on a real-time basis, you don't have to wait for batch updates, uploads, daily or weekly or what have you. Continuous visibility into all of the data that's flowing, that organizations are sharing in any kind of relative positions, whether it's financial positions, inventory, health records, you name it, but anything that's important to be able to see in real time. And it helps to automate many things that people today do through manual means. So, how do people share data today across organizations? Well, they often will export it into file or spreadsheets, right, from e-business suite, from databases, etc. It's a whole bunch of exports. Then you take the spreadsheet, the file, you send it to somebody over email, or you do B2B file transfer. They do some work on it, they make some updates, they send it back. You go back and forth until everybody finally agrees. You hope it's valid, and now you go back into your ERP system or database and you make the updates. But all of the in-between transactions have a significant chance of introducing human error, potential for fraud, and other things. So blockchain is a way to automate a lot of those cross-organization data exchanges. Now, typically in a blockchain system, we have what we call three layers or three tiers, right? Familiar with three-tier applications in a kind of a traditional sense, but this is 3 tiers of blockchain applications. At the bottom, you have the infrastructure. That's a blockchain platform. It has multiple nodes. Typically, those nodes execute smart contracts. They have copies of the ledger. The ledger typically has what's called a key value store for the current state of the data, and also blocks which have groups of transactions in them for the historical data. You have an ordering service which generates the blocks. You have a permission blockchain membership service that allows you to identify members, add new members, issue certificates, and so on. And that's kind of all of the infrastructure. On top of that, you have a layer of smart contracts, which we call chain code. And smart contracts are bits of programs that can operate on the ledger. They can perform regular business logic. They can be written in different languages. They can do get access, put access, delete, etc. They can also emit events, and infrastructure can emit events. And then the third layer are the actual applications, new applications or existing ones you might have today that somebody would develop, and those applications would invoke smart contracts, and they can also subscribe to events, and they can access the ledger usually. So you have applications that might register users, that submit transactions, that basically, if you think about it, or interoperate with the ledger through the means of smart contracts generally, right? So this is typically a development effort, and here you have as a development or integration if it's with existing application. So here's an example, right? Let's say we have a blockchain platform. It has a set of blocks. It has a current world state. It has smart contracts that deal with purchase orders and invoices, shipping, payments, vendor agreements, sort of a supply chain type set of primitive functions. And on top, you have actual applications like accounts payable, accounts receivables, and others in supply chain belonging to multiple organizations, in this case, organization 1, organization 2, that interact with the smart contracts, that invokes them, subscribe to events, and can also read the data. So that's sort of what a supply chain application on a blockchain would look like. You would have the actual platform hosting the ledger, providing the nodes, validations, etc. Smart contracts enforcing the business logic, the rules, maintaining the data. So you create a purchase order by invoking a purchase order smart contract, or you update a purchase order, or you query purchase order. Think about it basically as a method, a set of methods associated with purchase order data object that's then stored in the ledger. There is a lot of different technologies and frameworks One of the most popular ones is from Linux Foundation Hyperledger Fabric project. It has a number of advantages. And in fact, when Oracle a few years ago began looking at the different technologies out there, we picked Hyperledger Fabric as the specific blockchain frameworks that we are using. And in fact, it's interesting that in the recent study by the Cambridge University Center for Alternative Finance, they queried a lot of companies, 160 entities in 49 countries, what they're doing on blockchain and what they're using. And from the subset of 67 live production deployments, 48% use Hyperledger Fabric. And you see some of the other ones out there. But by far, Hyperledger Fabric is the most popular. And the next identifiable one is scored at 15%. It's a permission blockchain to begin with, so it has built-in concept of permissioning and membership services. It's programmable, so you have application chain code capability to define, run smart contracts. And you could do it in multiple languages, such as Java, JavaScript, and Go. It's scalable, so it's built for high levels of enterprise scalability and performance. It provides confidentiality means. You have ability to segregate subnet blockchain into multiple channels, which is separate ledgers for isolation, and different members have access to different channels based on what they're authorized to see. There's a concept of private transaction data, access control, and other things. And it's very modular, so you can plug in implementations of different things, which helped us from a perspective of developing a product significantly, because we wanted to be able to improve on the open source and plug in some of the Oracle technologies under the covers while still maintaining compatibility and not impacting any of the protocols, APIs. And it's really a strong advantage of Hyperledger Fabric that is built to support that. Now, it's interesting that there is over 250 organizations that are members of the project. There is a very large group of maintainers and contributors. The Hyperledger Fabric is currently on version 2.2, so it's been advancing very rapidly, evolving every few months, every quarter there is a new version coming out usually. And as I said, in terms of production deployments, it's by far the leading technology out there. Now, when blockchain technologies initially came out, particularly in an enterprise space, there were a lot of challenges, early challenges in that space. Lack of plug and play for like integration with ERPs and very complex APIs, asynchronous programming models, etc. Production readiness just wasn't there, right? I mean, it was open source and needed a lot more support there. You have continuous evolutions that, because of the rapid changes in the technology, often made it difficult for people to maintain compatibility and migrate from version to version. And there were a lot of kind of operational challenges, both from a business perspective and IT operations perspective. So a lot of things have changed. There is some market data here. IDC predictions from the Futurescape 2020 predictions estimate that by 2023, enterprises will invest nearly $11 billion in blockchain services and consulting, implementation, maintenance, support. And 1/3 of that will be spent on managed services, we call blockchain as a service, which, as it happens, that's one of the options we're offering in our Oracle Cloud environment. And we're seeing significant volume. I would say probably close to 80% of our customers are, in fact, using this cloud offering. There's also a survey from Deloitte that was published earlier this year, talking about a survey of over 1,500 industry leaders. I think, well, actually 1386, almost, no, here, 2020, 1488, almost 1,500, across many countries, where where business leaders now see it as an integral to organizational innovation. So they're really investing. And you can see that in the shift to production deployments from 23% having blockchain deployments in production last year to 39% this year overall. And if you look at large scale companies with revenue over 1 billion US, 46% of them have put blockchain in production. All right, so that's just a little bit of a primer, if you will, on enterprise blockchain and what we're seeing in that market. And now, what's Oracle position on this? Our vision is that enterprise blockchain is going to be a very significant technology that provides benefits to business and organizational networks, right? And when we say organization, we mean things like non-commercial organizations, government organizations, etc., in addition to businesses, by either helping to significantly optimize existing networks or rapidly develop new ones. And we're seeing a lot of new ecosystems formed around blockchain technology based on this notion of trusted transactions and ability to maintain single source of truth without requiring intermediaries, right? And that's really what's so new and revolutionary about blockchain. Now, our strategy from a kind of market perspective is we're working on making blockchain adoption easy and quick for enterprises. And if you remember back to my prediction, about 50 to 60% of companies using blockchain in the next few years, let's say 3 to 5 years, we think this is going to be a significant factor in enabling them to have very easy and quick ways of using it through a number of different entry points. So we provide the Oracle blockchain platform, which is available both in the cloud and on-premise offerings. There are some people who want to run it in Oracle Cloud, and for some strange reason, some people don't. They want to run it on premises, or they exist on premises and run it in a third-party cloud, which is fine. We support it. We also, so this is basically for customers or developers who want to build their own solutions. And the platform caters to a variety of industries and very horizontal kind of platform, right? Plus, we have vertical solutions in our SaaS application development teams called Intelligent Track and Trace, which is a solution specifically built for business users in supply chain management that don't want to deal with the details of the blockchain, but what they want is to have the benefits of the blockchain in the application. And so this application is built on top of the platform and makes it easy for people to enroll, brings their ecosystem partners together, and track things. Now, as I mentioned, we try to make blockchain easy. We try to make it very straightforward for enterprises to get started. So we make it easy to deploy. It's pre-assembled with automatic provisioning. It's all hardened. We take open source and invest a lot of time and development energy into improving on it. We have made it easier to integrate with a variety of systems of records and back office applications through REST APIs, enterprise adapters, client SDKs, etc. And it integrates with both cloud and on-premise applications, Oracle and third party. We make it easy to secure in terms of identity management, membership, on-chain access control, fine-grained access control lists, and so on, many capabilities. Make it easy to operate and manage without requiring a PhD in blockchain. So we provide the best-in-class administration tools and console with REST APIs and a web UI, very intuitive, easy to use, enterprise-grade, built-in high availability, disaster recovery, lifecycle management, built-in patching support, and many other things. And we also make it easy to expand with flexible topologies that allow customers who might start with a few nodes and a few organizations in the ecosystem, expand it broader to multiple clouds, hybrid deployments, cloud and on-premises, and so on. And interoperability with third-party Hyperledger Fabric nodes from other vendors, right? So we have today in production deployments where customers or partners have mixed Oracle, IBM, Microsoft Azure nodes in a single blockchain. Now, not only do we focus on infrastructure and operations in terms of making it easy, but also on the application side. And we do two key things here. First is we are expanding our portfolio of industry solutions, working with a lot of partners, ISV, system integrators, and so on. And we've recently introduced a component called Blockchain App Builder, which then helps customers who want to build custom applications do it faster and easier. So this is sort of development tools that not only allow you to go through development and testing faster, but can help generate the chain code for you automatically from declarative specs, right? So you can kind of spec out what the asset is you're tracking, and we will automatically generate the chain code and provide the tooling for you to test it and deploy it. Now, as I mentioned, Oracle has multiple entry points into blockchain technology. So we have our blockchain platform cloud, which is based on Hyperledger Fabric, highly available and enterprise grade. We add API gateway, console, operational tools, integration capabilities, etc. And that's been the product that's been available for the longest time, over 2 years now. Last year, we've introduced an on-premise version of the same platform. So you deploy differently from the cloud, but the same administration console, same functionality, same features and APIs built on Docker containers and so on. We have the SaaS application, Intelligent Track and Trace, which integrates with a variety of Oracle Cloud offerings in terms of getting the data from them and enabling users to track and monitor transactions and associated documents and assets, etc., in a nice kind of a SaaS application UI. And then we also have we've introduced this year blockchain tables in Oracle database that are specifically built to mimic some of the properties of the blockchain. So it's insert-only set of database tables with cryptographically hash-chained rows. We create metadata columns to create the hashes and change them. Ability to optionally allow users to add their PKI signatures on each row, and also provide the database signed digest across the entire table. And this is all available through standard Oracle database facilities and SQL and so on. So as I mentioned, we started our work around 2017 when we joined Hyperledger, released our blockchain platform in 2018 in July. At this point, we have over 250 customers on it, many in production, maybe about a third to a quarter in production deployments. The rest are in pilots and POCs and build and so on. Last year, we also introduced this intelligent track and trace SaaS application in the summer, and then our blockchain platform enterprise edition, blockchain tables in Oracle database in February. And then most recently in July, we've introduced Oracle blockchain platform Gen 2 cloud service, significantly renovated, re-architected, and much improved cloud service. All throughout, we focus on meeting the key demands from two classes of customers, right? People who are still experimenting. They need to be able to do a quick use case. They want to be able to get in and out of a POC in a matter of a few weeks, maybe 4 to 6 weeks maximum. And they want everything quick and easy. And then we have people who are actually looking to deploy, build production applications. They want it to be a production-ready environment with performance, security, plug-and-play enterprise integration, supportability, all of the things that you would expect in the mission-critical enterprise software. And so we provide that as well. Right? So those kind of the two sets of capabilities that we try to focus on and continue to hone our efforts in. So I mentioned we started with Hyperledger Fabric from Linux Foundation. It looks like 2 years ago, actually 3 years ago, when we started looking at it, it was the right bet because it's still the by far preferred technology out there. It has a lot of the benefits I already talked about, so I'm not going to go through this. It's organized around a set of 4 types of components, right? You have a component called Membership Service Provider, otherwise known as Fabric CA. This is the certificate authority that issues and validates PKI X509 certificates. There are peer nodes, and peer nodes come in 2 forms. You could have a peer node that only maintains a ledger and world state and validates transactions, or a peer that maintains a ledger and executes smart contracts, right? What we call an endorser. Endorsement meaning they've executed a smart contract and then they've digitally signed the output of that. You have ordering service. Now, ordering service gets the results of the execution and it creates blocks after transactions, right? And then you have client, which is the very first component that interacts with the blockchain to enroll the members, get the certificate. It will send the proposal to the peer to execute a smart contract method. It will get back the endorsements from one or more peers, depending on the policy. It will then group all of them, ensures that all of the results match, sends them to the ordering service, which is a cluster of orders. They go through a consensus mechanism to agree on the sequence of transactions and how many transactions to put in a block before the block is created. The block is created, everybody agrees on that block. They send it back to the peer. The peer goes through the validation aspect of that in the committer component, and then updates the ledger, updates the state, and potentially issues a response and event back to the client saying transaction's been committed. That's kind of the flow. Now, you could deploy all of this in one organization, or you can segregate them across different organizations. It's up to you. You could have organizations which are providing only orders, organizations which only run peers, and organizations which are clients only, right? And don't run any infrastructure. So it could be somebody with just mobile app, for example, talking to somebody else's peers. So a great deal of flexibility in how you deploy it. Now, if you wanted to build this from the open source, you go to the Hyperledger Fabric, you download the code, you get all these components, but it takes a lot of work to put it together, and they have a lot of dependencies as well that they rely on. They have to bring together. You have to do identity management. You have to bring your own event management, container lifecycle management, tooling for configuration, monitoring, and so on. So let's say you go through and you spend a couple of weeks, maybe a month, to integrate all of those things in. And maybe you're okay to do a POC, But then you decide you want to put it into production, you have to do a lot more. Autonomous recovery, lifecycle management around patching and upgrades, scaling, dynamic scaling in particular, disaster recovery if you want to run it across multiple data centers and so on. So at Oracle, what we decided, we're going to go ahead and put all of this together for you in an Oracle managed blockchain as a service, so PaaS level service. It's all pre-assembled. You can go to Oracle Cloud. It takes a couple minutes. You provision it. It's up and running. It's open. It integrates with peers of non-Oracle blockchain providers. It has a plug-and-play integration with a variety of on-premise and cloud applications. It has all of this enterprise-grade capabilities, high availability, etc., automated DevOps. Everything's built in. And it allows you to then focus on building the applications rather than the underlying infrastructure. We've done a lot of work around Hyperledger Fabric, made it into a managed service, built all the provisioning and entity integration, access control, put an API gateway in front of it to make it easy to interoperate using REST APIs instead of the asynchronous APIs that it comes with. A management and operations console for dynamic configuration and automation. We replaced underlying databases that were LegDB or CouchDB with BerkeleyDB, which is an in-memory, well, it's in memory and on disk, but it's a much faster database. And we provided SQL-based access. So SQLite on top of BerkeleyDB allows chain code developers in Oracle blockchain to use SQL-based risk queries. And we created a data pump to shadow the data from the blockchain history to Oracle database into a relational schema where you can hook it up with all sorts of analytics and other tools. So if you are using Oracle Cloud today, you can go into a CI menu, right? And right here at the bottom, you're going to see blockchain platform option, just above marketplace. That's how I remember where to find it. When you click on it, you have a provisioning pane, and it looks like this. You go through the provisioning. Basically, it creates all of this environments for you out of the box, right? Again, think about what you would have to do to create it from open source. So you get Oracle Managed Blockchain as a service. You have ability to specify if you're joining an existing network or creating a new network. Different editions. There is standard edition for development and test, very low cost, or enterprise editions which have high availability built in, come in 4 different shapes. And you can also dynamically change the shapes and reconfigure them in between as well. You click create. So when you get the first screen, you click create blockchain button here. Then you get this screen. You fill this in, display name, description, and then you click create button here. And 5-10 minutes later, you get an email saying it's all set up and provisioned. And you can go ahead and access, and you access it through a console. This is what a few screenshots from the console look like. It has a lot of administration things to manage and monitor your environment. There is a dashboard view, a network view, nodes view, channels, which is how you subnet, chain codes, which is smart contracts and developer tools, and a lot of monitoring, troubleshooting, chain code lifecycle management tooling around smart contracts and so on. Again, I won't go through all of the details here, but we've done a lot of work to improve on the underlying open source with things like zero downtime managed patching, network joining wizard, continuous configuration backups, and multi-data center HA in Oracle Cloud across availability domains, performance improvements, security improvements, and add-ons, and a lot of development. Most recently, we've released this blockchain app builder, which is an IDE and a data model, a code generation set of tools. There's some unique capabilities that our blockchain provides, right? So we have productivity enhancing SQL support, which typically in a blockchain environment operating on key value data you would not find. Easy data visualizations by integration with Oracle database and analytics. Ability to manage the slow tech member organizations and onboard them as clients only without requiring any infrastructure. If you think about, let's say in agriculture, right? Some of your participants might be farmers who grow some food and you want to report some data, maybe scan some data. You are not going to have them come in and operate a node. All they can operate is a mobile application, and that's sufficient to join. Confidentiality and privacy support. Bidirectional integration through the API gateway, including event subscription model. And very flexible, interoperable topologies, as I mentioned earlier, spanning multiple clouds, multiple vendors, on-premises cloud, etc. So I'm not going to go through all of the individual details here in the interest of time, but you'll get the slides and you'll be able to see the benefits of using SQL queries, for example, instead of working through the sort of key value calls. the rich history where we pump the data. Like I said, you configure Oracle database connection, and you then specify for each channel if you want to use rich history, just a checkbox. And that data then goes and gets updated into Oracle database schema for every transaction. As we get blocks from the ordering service in the peer, in addition to updating history database in the peer, we asynchronously pump it into Oracle database. And then you could do analytics and all kinds of things. Now, you could do this, like I said, for analytics. You could do this for high volume reads. If you have a large number of read-only operations, you can consolidate blockchain and ERP data in a data warehouse. Or you might have multiple blockchains, and you can consolidate, again, that data into a single rich history environment and do all kinds of operations in that. Talked about solving the onboarding challenge for client-only organizations. So you could have essentially some organizations running their own nodes and then shared nodes that client organizations can access by having simply small applications, web or mobile. Confidentiality and privacy, we've introduced this fine-grained access control list mechanism, which is unique to Oracle blockchain at the moment. We are planning to contribute it to open source at some point once we get through all of the legal approvals, but for now, it's an additional benefit in the Oracle environment. You can define access control lists, and you can then use and validate them in your chain code to determine who has access. On the integration side, we cater to different integration modes, right? So the easiest is our REST API gateway that provides synchronous and asynchronous transaction invocation and events and queries. We also support client SDKs in different languages. We support integrations through adapters in Oracle Integration Cloud and on-premises source suite adapters. And then we have this built-in application that actually has zero integration requirements because it's already pre-integrated with the blockchain. I mentioned the release that came out in July. We really focused on the requirements of our leading production customers that needed to achieve higher degree of availability, resiliency, performance, dynamic scalability, and so on. So we've improved those features. We automatically distribute, for example, when you create an instance in the cloud across 3 availability domains. So typically in a region, we would have 3 separate data centers in the metro area, at least 20 kilometers apart. And we automatically locate all of the nodes and components across those 3 data centers for you and replicate everything. Dynamic scale up at individual node level or the entire platform instance on demand as well. We picked up one of the more recent versions from the community edition of Fabric 147. And we use Raft protocol for decentralized ordering to allow multiple participants to contribute ordering nodes, which provide significant scalability and additional privacy benefits. And we've invested again into the Oracle unique features around auditability with Oracle database blockchain tables and on-chain access control library for security confidentiality. And there is a blog here that goes into a lot more details on all those features. A couple of words on our enterprise edition. As I mentioned, this is something for customers who might need to meet data sovereignty, data residency regulations, maybe government organizations, maybe customers that operate in certain countries where there is data sovereignty requirements. We see a lot of interest in China, for example, in the Middle East and some other countries where governments really don't like people putting stuff into third-party clouds. So it's the same version, basically same APIs, portability, but it runs inside the VMware Oracle VirtualBox environment. Very easy to set up, and it interoperates with all of the other flavors of Oracle blockchain and Hyperledger Fabric. And as I said, the same thing, but runs on top of the VirtualBox or VMware environment in a customer data center or third-party environment. You deploy it through a platform manager. So this is basically a single VM that comes up. Then you can specify how you want to deploy it, maybe across multiple data centers. You have developer shapes, enterprise shapes, all of that's managed through the platform manager component. And you see the UI here, where you can define the instances. You can go through the create instance wizard, define your cluster configuration. You can operate, start, stop, scale out, etc. You specify the domain address, fully qualified domain name for each of the different components for VMs. And then we'll go ahead and manage it for you using Docker Swarm. There is different models of deployment. You could deploy it in a kind of a private way, where you have single platform manager. You deploy, let's say, a set of instances, link them into development blockchain. And then you can create a set of administrators, and they each can create their own instance. And then you can link it into production blockchain. Or you can deploy it in a consortium, fully decentralized model, where each organization has its own platform manager. They create their own instances, and then they link them into a production blockchain. This will be much more decentralized deployment model. It supports scale out, scale in, all of that I talked about earlier. So you have ability to deploy this in Oracle Cloud. As I mentioned, we have about 13 different data centers where it's available today and more coming. And then you can also deploy it in customer data centers. You can deploy it in third-party clouds, and you can also interoperate with open source Fabric. And we have done interoperability testing with other Fabric, Hyperledger Fabric deployments from IBM, SAP, Azure, and I think more recently one of the customers worked with Alibaba Cloud as well on their Anbas blockchain integrating with ours. So full flexibility to deploy this in completely private deployment on-premise, a fully cloud service across multiple clouds, or cloud service and on-prem. And this is a particular example with a partner called mipasa.org, which is put together by a partner of ours called Casera. They're using nodes from Oracle, from Microsoft, and from IBM, all in a single network, which is quite interesting. So just to summarize, right, you get the benefit from this Oracle blockchain of both the validated community edition, and you get the Oracle engineering investment as well. You also have the benefits of being able to integrate across not just blockchain, but other components that typically used as part of the architecture partner, right? So if you need to integrate a variety of ERP systems or other applications, we provide adapters in the integration cloud or source it on premises, feed into Oracle database, analytics integration. You end up doing mostly development work around smart contracts and front-end application, and everything else is kind of plug and play. But to make it even easier with smart contracts, as I mentioned, we created this blockchain app builder. App builder is a downloadable component from the developer tools tab in our blockchain cloud service. You have option to use two interfaces, Visual Studio Code extensions that you see here, or for power users who don't like to use GUIs, they can use command line interface as well. You can scaffold the project as part of the development lifecycle, and support auto deployment with the local Hyperledger Fabric network, and then also ability to handle all of the packaging and deployment into Oracle Cloud Service or on-premise version. And we support code generation, as I mentioned. You can specify asset definition, if you will, and will generate the chain code automatically for you. We support a decorator pattern, so you can define properties and validation rules. And we will generate the basic create, read, query, or update functions for you automatically. And then you can add custom business logic as well. What's really cool is if you go and you update the specification, we will automatically, on the update, regenerate those chain codes for you wherever they are deployed. And we provide a couple samples built in. We continue to invest heavily into development and integration focus areas to make it easier for developers, operations, for administrators, and then the infrastructure and interoperability, which is a very big topic. I'm not going to go through all of this in detail, but we have a number of releases planned. And we've also added support, except for the blockchain app builders that came out in September, and now enhancing it to the first version available on Mac and Linux. We're going to be releasing in November Windows version, adding support for tokenization support later on in next year Q2 timeframe, and a lot of enhancements coming up as well. Now, this is kind of a summary of our strategy, right? To try to make it enterprise ready, to make it easy, quick to deploy, very quick to deploy, pre-assembled, dynamically configurable, pre-integrated with a lot of components, and easy to integrate. So you can use our REST APIs, you can use adapters, you can use embedded blockchain APIs in a variety of Oracle products, and we can help to extend boundaries of enterprise applications easily with blockchain. So let me pause here. Take a couple questions. Let me see on Q&A here. I see a few questions here, right? So can you state some clients that have implemented? Yes, I'm actually going into custom example section right after this, so hold this question for a minute. How will the data be updated in a node if there is internet failure? So there is a gossip protocol that peer nodes use. Whenever a node comes up or it loses a connection and reestablishes, it will check to see if it has the same number of blocks as all the other nodes. It's called block height. So if its ledger has the same number of blocks, and it will get the missing blocks from other peers through the gossip protocol automatically. So it's kind of built-in function. What is the smart move converting existing traditional application to blockchain? or to only update a few parts of the application which carries confidential data. So it really depends on the nature of the application, what it's doing. Um, if you have applications that's involved in cross-organization business processes across multiple organizations, you might want to replace that part of it with a blockchain, right? I mean, if you think about ERP systems, right? The core functionality of the ERP, you don't want to reinvent on a blockchain, but anything that involves sharing data with other systems, that's where blockchain would come in useful. Can we achieve blockchain on a different type of databases? Well, you would need to build some integration flows between those databases, but you could in principle, yes. At high level, what defines the actual logic of the blockchain? Consensus or smart contracts? So smart contracts defines a custom business logic specific to the applications. Consensus mechanisms really are there to define how data is shared, right? What is the requirements for everybody to agree that the same result is valid across multiple copies of the ledger. So it's more of a foundational kind of capability. There's different consensus mechanisms, but ultimately they're not application specific. What is application specific from a business logic are the smart contracts. All right, so let's go and talk about custom examples. So we have 4 different kind of paths to market, that we work with, and I work a lot on. And the platform itself is great, but without applications, really, it's not going to be very useful. So we do a lot of work on custom applications through Oracle Solution Engineering Hubs. We work with Oracle development teams in various business units to help them create applications like Intelligent Track and Trace. We work with system integrators like Infosys and Deloitte and others, Cognizant, Tech Mahindra, etc., to work on joint projects, but also many of them build packaged applications or accelerators, at least, available on Oracle blockchain. And we also work with ISV applications as well. There's many ISVs who are building and deploying the applications across many verticals. As I mentioned, we have over 250 customers with about a third to a quarter in production. You see some examples of the use cases here in financial services, supply chain, public sector, healthcare, some of the more common areas. I'll show you some of the specific examples here. So for example, in supply chain, provenance traceability is very important. GATS is an organization that works closely with Singapore Customs on country of origin certifications and tracing across multiple countries in ASEAN and China. Kana Shoes is a footwear retail store, right? Fashion and footwear, and they track the authenticity of the handmade shoe products. Circular works with Volvo on the electric vehicle batteries and essentially helps trace the battery supply chain and the ingredients, cobalt that goes into batteries across multiple organizations involved. Food authenticity is very important, right, and sustainability. We have this project, by the way, the ones in mustard color are in production. Extra virgin Italian olive oil, which is a company called Certified Origins, tracing a lot of the farmers who bring olives, plants, the mill plants that actually mills the olives into oil, distribution facilities, and so on. GE, we worked on an intercompany ledger project for cross ERP billings. They have over 100 different ERP systems across all of their subsidiaries. You can imagine the complexity of reconciling that. Luxury goods and counterfeit traceability. So I mentioned diamonds earlier. Hyperledger is one of the leading companies about diamond traceability from mining to retail on Oracle blockchain. Beretta Guns. In India, we did a project, I believe, a year and a half ago with Strides Pharmaceutical and under NITI Aayog sponsorship on anti-counterfeit drug tracing in distribution chain. In transportation, maritime shipping documentation with this Global Shipping Business Network, which is a consortium that's responsible for around 50 million shipments a year, about half of the worldwide container shipping capacity with 6 carriers. Online training and education in China and in Saudi Arabia. Financial services, right? The cross-border funds transfer, KYC solution, asset tokenization, smart insurance, parametric insurance, this was in Italy, and various government, public services, healthcare, and so on. So I thought what I'd show you a little bit more interesting, perhaps, some of the production deployments that have been running live on our blockchain platform. So funds transfers and eKYC, non-performing NPL loans marketplace, retail cards for the unbanked, across the world. This is a lot of different platforms in financial services. In supply chain, Coiners, which is a partner based actually in India, working with one of the largest metals producers in India on B2B platform for inventory visibility, authenticity, invoice financing, etc. Mentioned Hyperledger, Mipasa we talked about. This is intellectual property rights organization in Italy, Canashus, health organizations, and some of the other ones I touched on already. There are some links here. You can go look at the case studies and such. Now, here's some more recent example. I mentioned the instant account opening eKYC solution. This was implemented by Jordan Ali Bank in Jordan. They wanted to provide touchless onboarding service. They ran many promotions, and what happened was customers wanted to sign up, but it used to take them 10 days to open an account, required a lot of paperwork and branch visits. They wanted to eliminate that, so they replaced it with a mobile app that stores all of the personal information on chain using Oracle blockchain in terms of national ID card, information filled into the forms, signature scans, and there is a visual component here basically where they have a video conference with somebody at the bank to collect additional information. And through this video call, at the end of the process, they basically have an account open instantly, right? The account owners can then grant access to their partners to be able to use that KYC profile to offer various services. We have EastNets recently deployed for real-time anti-money laundering watchlist updates. They provide applications to banks for AMLs, and the data feed, what's called blacklists, published by various U.S. Treasury, UK Treasury departments, etc., people you're not supposed to be doing business with, is what they work on, right? So instead of having to go through periodic file uploads and have gaps in between, they wanted to make it much more real time. So they implemented this mechanism that pulls the data from the different organizations that publish blacklists into the blockchain, and then the financial institution applications can access this data in real time. And this is the one that I mentioned, that the Coiners, working with Hindalco, which is a large metals producer, manufacturer in India, providing this B2B platform where they work with what they call tollers. This is organizations that take the metal products from Hindalco and do final finishing for custom manufacturing requirements. And there is a blockchain in place based in Coiners that's recently been implemented to track all of those flows. And the most recent one is in Europe, implemented by Trace Labs on Oracle blockchain for milk supply chain. It turns out that in the milk environment, the pricing for farmers delivering the milk is very indeterminate. It depends on many factors. It takes actually a lot of work and a lot of inputs, quality testing, lab testing, etc., and many other things to determine what the actual price would be. So they've implemented on Oracle blockchain smart contracts to determine the payment based on a lot of inputs from various sources. And they calculate the price, and the smart contracts can then access this origin trail trusted data in order to determine the appropriate inputs. And then they go ahead and create a payment file. SEPA is a European payment file format that then allows them to automatically generate payments. And all of the information, all of the inputs being tracked, all of the data sources and the calculations are all transparent. So the farmers can go and easily see exactly why the particular price has been calculated for their particular milk delivery. And it's part of the Smart Agri-Hubs initiative in the European Union. So just in a sense of some of the applications, I mentioned intelligent track and trace, right? So this is an application for business users built by Oracle SaaS team in supply chain management. And it's really focused on bridging the gap between kind of the technical value propositions that I talked about and the things supply chain users care about, right? They care about multi-tier visibility, chain of custody, provenance, track and trace, etc. So Oracle built an application to make it easy to deploy called Intelligent Track and Trace to turn this technology and the data feeds into answers to these requirements. And so this application provides full visibility. It provides a full system to visualize where the products have been, where they are, track the different records. It can detect anomalies and can give you access to the root cause analysis on the data. It has ability to track compliance with various rules. And of course, all of the data is stored on blockchain, integrated from a variety of Oracle systems, typically in a cloud, supply chain, ERP, CX, IoT cloud, etc., to be able to give you full visual experience and ability to track and drill down. And also there is simulation process that allows you to actually simulate the flow of documents and products, items in this environment across different stages. And then it will track based on those stages, right? And we've extended it to do product lineage, intelligent cold chain, where we also track temperature and IoT sensor data, and then aftermarket warranty and usage tracking. So it has pre-built integrations with a variety of Oracle systems today and more coming, plus REST APIs for custom integrations. Now, there is a number of other applications where you can think from an Oracle applications perspective that align with Oracle SaaS, where blockchain can make sense. So in ERP, for example, financials, we worked on intercompany reconciliation and settlement and invoice factoring, where you are essentially putting invoices in the market for discounting and integration with accounts payable, accounts receivable. In supply chain management, integration with Oracle transportation management for shipping data, provenance tracking, and CPG vendor onboarding and validation. And NetSuite, similar use cases, because NetSuite is really sort of combination for supply chain management and ERP financials, but for smaller customers. Human capital management, verification of education credentials, employee onboarding, and in CX, customer experience. We've acquired a company called CrowdTwist about maybe a year ago. That's our new CX system, and it provides for loyalty applications. And when you want to make the loyalty system work with multiple brands and multiple vendors, this multi-brand extensibility is based on blockchain, and we have some partners implementing that. Now, I mentioned some of the system integrators. So there is a number of solutions. For example, in farming from Cognizant and Infosys, Sustainable Agriculture with Reward Systems. We worked on this project under the auspices of World Bank for Indonesia palm oil sustainable production. Tech Mahindra has a solution around aviation records management built in Oracle blockchain. PwC has a solution for contract and licensing management, particularly suitable for entertainment industry. Reply has smart insurance solution built in Italy that's being deployed across a number of insurance companies and banks. And Deloitte has built a couple solutions. One is intercompany reconciliation and settlement, and another one is around this digital bioseal and tax stamp tracking in Europe. And then finally is ISV applications that I mentioned. So we have a number of them across different verticals. I will not go through all of the details, but just highlight the three most recent ones. FinTech is the one I talked about the KYC solution. So the FinTech has built it as an application, and now it's deployed at Jordan Valley Bank. EastNets, which is secure real-time anti-money laundering watch list, and Coiners, which has this markets and B2B platform that I mentioned earlier. And this is some more details on those solutions. So this is the eKYC solution. It's actually from Norblock, which is a business-oriented eKYC that allows many companies to onboard to a bank and collect and provide all of the relevant data that they need, verify their identity, and design sort of custom workflows for onboarding. DAML is a language created by DA that is interoperable across multiple blockchain. We have a solution for verifiable identification credentials for COVID-19 testing results, obviously a very important topic these days. And we have a partner called Wotun that has built a solution that allows people to track and then show on a mobile phone the results of tests that have been tested and cleared. Zua, which is kind of a low-code development platform that provides a lot of pre-built smart contracts on top of Oracle blockchain. So this is a bunch of customer examples. There is a lot more. You're welcome to come to oracle.com/blockchain and see a lot of the use cases there. In the interest of time, I will very quickly go through the blockchain tables, because I wanted to introduce this technology as well. One of the challenges with blockchain is that, as great as it is new technology. You need to have specific knowledge of the development partners, and you also need to form organizations, consortiums, and business ecosystems, which are going to take some time. They require approvals of multiple parties and so on. So we see a number of customers that have actually identified the need to deploy blockchain in a single organization, where it's not a decentralized application, it's more centralized, but immutability and tamper-evident data storage and ability to validate the data has not been tampered with for fraud prevention is very important. So we've introduced this concept of blockchain tables inside Oracle database, right, to make it much easier to use and integrate without requiring new infrastructure, simply by allowing you to use Oracle database and create a new type of a table. It's simple to use. You basically have new syntax, create blockchain table. It's insert-only table where rows are cryptographically chained, and you have verification functions in PL SQL. It can be mixed and matched in transactions and queries with other tables, just like anything in Oracle database. It is a centralized model, so you have an environment where you have a trusted third party that actually runs the ledger, and the other participants may not trust each other, but they trust in the third party, like a central bank, like an escrow company, like a stock exchange, etc., which is the case for many applications today, majority of applications. In Oracle database, we have been introducing this concept of a converged database strategy, where other vendors are providing point databases for each individual scenario or type of data. We support all different data sources in Oracle database to make it easier to interoperate for applications that need more than one type of data. And blockchain is just another example of that. Instead of having to have separate databases and have to essentially deal with event replication or ETL type replication across them, you now can use a single converged Oracle database and have all of the different data types available in it, whether it's JSON, whether it's spatial, whether it's graph data, blockchain type data, etc. So as I mentioned, blockchain tables are created to provide an insert-only environment. You cannot delete rows, you cannot update rows, you cannot add, drop, rename columns, drop partitions, etc., right? None of that is allowed, only insert, sign, verify, and select operations. We create a set of metadata columns on top of the addition. You create, of course, your own data, you define your columns. And then we add these hidden columns. And in those hidden columns, we maintain instance ID, chain ID, timestamps, the hash that's calculated of the row. But the hash is calculated over the row data plus the hash from the previous row. That's how we chain the hashes together. So it provides user fraud protection, admin fraud protection, and because you can use PKI signatures to sign the data, it provides identity fraud protection as well. There's a number of applications, as I mentioned, that can benefit from this capability. It's available today in 20C database. It's available as preview. If you go into Oracle Cloud, you can see in Oracle Cloud, when you provision a database in the VM environment, you can select 20C preview version. It's built in right in there. So some examples of use cases, for example, government use cases around reducing fraud and corruption by protecting law enforcement chain of evidence. Financial services, of course, financial ledgers, trading records, payments and funds transfers. You can increase consumer trust in retail and supply chain, credits and refunds, shipment refund history, Sarbanes-Oxley for compliance, in corporate treasury applications, legal services if you need to maintain integrity of document notarizations, chain of evidence, property record, etc. So as I mentioned, you can go into Oracle Cloud. You need to select virtual machine type database and logical volume manager, and then you can select 20C preview version from the version selector and create it. This will be available in the GA version in 21C database rollout that's coming out in a few months, and we're also backporting it. If you're using 19C database, you'll be able to apply 19.10 release update targeted for calendar Q1 timeframe in a few months, and you'll have this capability available. So very quickly, you create blockchain table by adding the term blockchain in front of the table and a few clauses, right? So no drop, you can decide how many days, or no drop period. No delete, you can decide if you want to allow a deletion after a certain period of time as well, and a hashing clause. All of this kind of a special blockchain clauses, right? So no drop basically means the table cannot be dropped if the newest row is less than a certain number of days. And optionally, you can say until end days idle, or just no drop period. Row retention clause, no delete. You could say no delete, or no delete until end days after last insert. And you can also add locked, which means it will not be alterable if you say locked. And then this is fixed clause. in terms of the hashing that we use, because when we replicate it in the future to other databases with other versions, there may be different hashing algorithms, and we need to know which particular hashing versions use, because obviously the integrity of the hashes is important. A number of functions in PL/SQL packages to delete rows, verify rows, sign rows, etc. So you can create PKI signatures. The PKI signatures are calculated outside of the database as your private key. You need to first add certificate into the database. So if you have a PKI certificate, you can use this add certificate function. When you call sign row, you specify certificate GUID returned here, and the actual signature, and the particular row ID. And then we calculate and ensure that based on the public key, we can verify that your private key signed row matches the original data in the database. All right, so this is blockchain tables. There is some concepts out there. There are some similar things like AWS, QLDB from Amazon, but it's very different thing because it's very specific journal kind of set of entries for particular documents in QLDB, whereas ours is more generic, general purpose table. You define your own structure, your own columns, your own fields. You can use standard SQL to interact with it. You could have transactions spanning multiple tables, blockchain and non-blockchain, a single query spanning multiple tables, and so on, which is something you cannot do in AWS. Very quickly, just to wrap up here, right? So just as a summary, we have a very advanced blockchain platform available for enterprises, which is open, mature, interoperable with Oracle and third-party Fabric instances. It helps to focus your investment as a customer or as an ISV on application value add and not on infrastructure, right? We take care of all those underlying infrastructure. And we provide a lot of integrations with enterprise applications and blockchain native applications. And we have strong momentum in the field with a number of production customers across various industries, migration from other blockchains, and major solutions coming from system integrators as well as ISVs as well. And then we have this blockchain table technology, which is simple, specialized insert-only table with cryptographically chained rows. Users can get application transparent protections. They can sign and verify the data. This is a capability that we'd encourage you to explore and use if you're already Oracle database customer, which I imagine most of you are. You get the benefits of immutability, and you can satisfy many current use cases in enterprises for things like immutable transaction logs, audit trails, etc. You could, for example, have today regular tables that you're using today. You can create a blockchain table, create a triggered sort procedure to capture all of the updates going into the regular table, and create this audit table for all of those updates in a blockchain table. Or if you have an application which by its nature append only or insert only, you can use directly blockchain table for that application as well. This is a little bit of a comparison between what you get with blockchain tables versus blockchain platforms. They both provide chain dependent only data that's optionally PKI signed in database. Everything is signed, PKI signed in blockchain platform by default because all the messages have to be PKI signed for permissioning, right? The big difference is that in the database, it's a centralized store model, so you can copy hashes externally for verification. In the blockchain platform, it's a fully distributed ledger environment that you can set up across multiple nodes. You have ability to do multi-party endorsements because it's a distributed ledger in a platform, which you cannot do in a database. In a database, the programming model is standard SQL, PL/SQL, etc. In the blockchain platform, it's smart contracts, which you can write in Go, JavaScript, or Java. The standards component, of course, SQL-based answers, SQL-based access, and Oracle database, versus interoperability blockchain platforms based on open source interoperates with a bunch of other vendors that using Hyperledger Fabric, right? And you see some examples of the use cases. Again, centralized immutable transaction logs, audit trails, SOX 404 data, financials, accounting ledger, etc., legal hold, centralized chain of custody versus more decentralized record keeping and audit trail, supply chain provenance across multiple parties, multi-party exchanges. You get the theme here, right? Multiple organizations. That's when you want to use blockchain. Now, we do a lot of work to help customers explore how to use blockchain. And some customers are different stages, so we can help you if you're just beginning with the discovery process and share with you industry's use cases, understand your needs, and then work through kind of a design and implementation, minimally viable product MVP with our solution hubs and our partners as well. So we have a lot of folks in the field that are able to support this. If you already have use cases and you thought about them and you want help implementing and designing, we can drop in kind of in the middle and help take you all the way through to an MVP and ultimately into production environment. Now, blockchain is not something we would push regardless of the requirements, right? I mean, it's important to ask the right qualifying questions to ensure that it is providing the right match and the right type of blockchain solution. And there is different kind of scenarios and patterns out there, such as reducing friction in business transactions and reconciliations, sharing decentralized records, tracking provenance, or enabling distributed marketplaces where people are exchanging information or exchanging something of value like tokens. So we would map to those. We can help with the business case, mapping from a technical capabilities to the impact they provide in business and ultimately the results that a CFO, CIO, CEO would want to see. We can work with you through an exploration stage and later on move into a POC and a pilot ultimately. And if you like the results, to production environment all the way. So I'll pause here and happy to take a few more questions. And so I see a couple of questions here. Is there an entry-level certification course available for blockchain Oracle University? So there are some courses available, but not a certification program yet. We're actually working on it and hope to have it available in the spring. If required, can we update the value in a table from backend in blockchain table using update query? Let me understand this. So you want to update the value in a regular table or in a blockchain table? No, actually, you cannot do an update query. You cannot do any updates. Once the data is recorded, right, the record's been inserted, the hash is calculated, it's linked to other hashes. There are no updates allowed in blockchain tables. All right, any other questions?
I think we are top of the hour mark. So, guys, if you have any questions, please share it in the Q&A section, please. Okay,
No, I don't
Mark,
see
if
any
you're
more.
done, then I can share my
Yeah,
screen.
let me just close by just a couple slides here. So I really like this quote from Don Tapscott. If you're not familiar with Don, he was one of the leaders in sort of early days of the blockchain revolution. Published this book called Blockchain Revolution: How Technology Behind Bitcoin Changing Money, Business, and the World. He has this quote about the future, right? People often ask about, what do you predict how blockchain will be used? His message and mine is the future is not something that you can predict, but it's something you can achieve. So get busy, get your hands onto Oracle blockchain platform or Oracle blockchain tables and start working on it and build your own future. There's where you can go to get more information. There is a bunch of Oracle websites where blockchain information is available. There is a developer ebook at developer.oracle.com. If you want to get right into technology, or you can look at customer use cases and blog stories. You can download the Enterprise Edition, which is available under OTN license, free developer license for 30 days. Or you could come to Oracle Cloud and sign up for blockchain platforms there. All right, so that's all I have.
Thank you very much, Mark. This is really, as you mentioned, so blockchain is new to our community, and I'm sure we will have more deep dive sessions on blockchain. Thank you very much for your time. So there are a few things I want to share. So it's very important to provide your feedback, and you can see there is a QR code here. Scan that and provide. It takes only 1 minute. And also, it's not only feedback. If you want to have any questions on blockchain, please post it in the survey. Also, if you're interested more blockchain sessions, please let us know through this feedback form, right? Important thing is Sangam 20 is back again. I know we are going to miss all the networking fun, but let us take advantage of virtual conference. We are trying to bring new speakers, new topics. Also, it is your turn to submit. If you're not ready, please share with your connections we need to identify the diamond speakers and learn from them, right? So call for papers deadline is 10th of November. So please make sure that mark your calendars. So what is coming next week? So we have Agile and DevOps for Oracle Cloud. So we have Shay basically talking about Oracle Visual Builder Studio. It's a platform for building code and development process. So it's really good topics. And also we have back to on the MySQL topic, migrating MySQL from AWS to OCI. This is a new service coming from OCI. It's a MySQL database service newly introduced. So please join that session, register. It's a very important thing is register and join, right? We also introduced, not only technology sessions, we are also bringing some motivational topics. So this is a very key topic. One of the best speaker from the Java community, but he's actually does a lot of motivational sessions. So 3 ways to grow your IT career to next level, right? So please mark your calendars again, register, and attend the sessions. So, with that, thank you very much for your time. Have a wonderful rest of the day and good night to Mark. With that, we are
Thanks.
closing the session. Thank you very much.
Thanks everybody for attending. Bye bye.